Now let's go ahead and start building a basic web scraper from scratch. So for that, let's just call this script as scraper.py. So we'll be building a scraper in Python. For that, we'll be needing some libraries. So let's go ahead and import them in order. So import pandas pd, import requests, uh, actually date time, import date time, then from bs4 let's import beautiful soap, and we will be needing time as well as import so I'll just explain all these libraries. Pandas is basically for getting the pandas data frame. Requests actually lets us access various website and make requests to different websites and all the URLs that we are going to be needing. After that, date time, not a very particular use, but we'll just need for this for annotation. Similarly, time is for annotation purposes only. Beautiful soap is a library that is mostly used for doing this kind of things. Beautiful soap is there. Then the scrapey and all these things are used for web scraping purposes. So for that, uh, first of all, let's go ahead and so let's go to Yahoo Finance and let's just see how data is actually represented there. So today we'll be actually scraping these values as these are constantly changing values. So we can directly scrape these values from the website and then store them in a data frame and then later analyze and perform different operations on the data. So right now we'll just scrape all this value, then this change and this percentage change that is there for different kind of shares. So Alphabet, INC or Google basically has the share named Google, and other than that it has another share known as GOOG. So these are the two shares. So what actually we'll do is we'll go ahead and analyze this website link or this URL at which we find the data. So let's go ahead and just get another example and let's see how this URL actually changes. So when I go ahead and look at this is the stock symbol that represent that particular stock. Every stock is basically represented by a symbol. For example, Reliance Industries stock is represented by this symbol. Google has GOOG and GOOGL as its symbol. So as you can see that whenever I change it from one to another stock, we see a change here in this place and this place. So whatever the stock name is, you see that stock name there. So GOOG, again this and this changed. So what we will do is we'll take this entire link, we'll copy it, and whenever we have to find one particular stock, we'll just put that stock's value here. For example, let's go ahead and change it to GOOGL and GOOGL and then press enter and see if we get a result on GOOGL. So yeah, we are getting a result on GOOGL if we just put GOOGL in both these places. So we'll just copy this, we'll move back to VS Code. Now let's go ahead and define a function. Let's call it get live data. What will pass it is the symbol that we are going to get the data for example GOOGL, DJI and all these things, and we'll pass the interval for which we want the data. So probably this will be in seconds, we'll keep it in second. Now we want the link from where we'll get the data. So the link will be this, and we want to replace this. So let's put a marker here, and we want to replace this again. So what we'll do is we'll put down in both these places, symbol, uh, sorry, symbol and symbol. So now whenever, if we go ahead and let's just say we want to print link, and after that we want to just go ahead and say that we define a main function. So main function is basically where we actually start executing our script. So in main function we'll just call get live data, we'll pass GOOGL, we'll pass it 5 here, and if name is equal to main. So if you're not familiar with this execution style or how scripts are executed in Python, then you can go ahead and look it up, but this is the basic structure. I defined a function, and then I defined the main function where all the execution will take place, and then I check if the main function, if the script is the main script, we start executing the main function in that script. So let's go ahead, let's save it, then we'll go ahead and try to run it and see what gets printed out as links. So cd module, okay, so cd module 3, so let's run it, python 3, and the script is called scrapper.py, or is it in the main folder? Where is it? Okay, so it's in the main folder only, so I'll have to cd back here. So it's in the main folder. So now python 3, now scraper.py. So it's printing this particular link. We put the symbol here, we put that, and okay, so if I just go ahead, and if I go ahead in the browser and paste this link, we'll get data related to this particular stock GOOGL. So now what we want to do is that when we have this particular link from where we can get this data, we actually want to get that data and store that data in form of a table or in form of a data frame. So what we'll do is that let's just go ahead and define a data frame in which we'll store the data. So let's call it initial data frame list. For now it's an empty list. So after that, what we want to do is we want to continuously try to scrape data from the website, so that we can actually get the data and keep scraping it over and over at regular intervals. Say example 3 seconds, so we will scrape one data, as this data is actually constantly changing on the website every moment whenever there's a change. So whenever we'll see a change, what we'll do is that we will get that data, then in the same interval after 3 seconds we'll get another instance of that data, another instance, and so on and so on. So yeah, this is what our basic aim is. So we'll mark a pointer start that will say datetime and dot now. This basically what it does is it actually gets the time that the clock is showing right now in whatever format that I want. So yeah, and then I'll convert it to string format of time, and I want to format it as, you don't have to actually worry about all these formatting, but it just keeps the data in a very arranged manner, so why not. So hour, and then minute, and then percent second. So this will represent the start time at which we'll start scraping the data. So whenever we start scraping the data, we'll say we are scraping live stocks for whatever the symbol is. So live stocks for symbol. After that, we want to keep on printing the table in which our data is going to reside. So for that, let's just keep a simple format. So let's just say 4 spaces or 5 spaces. 5 spaces for now. I'll just copy this space as we'll be needing it again and again. Or let's do one thing. I'll just copy this entire part. uh, so this will be there. Then again, so how many markers do we actually need? We need the date, we need the current value, we are going to scrape the change as well as percent change, as well as we'll scrape if the market is currently open or not, if the status of market is open as of now or not. So in total we have 5 markers or 5 attributes that we want to collect. So 1 2, another 3 4 and 5. So yeah, 5 markers. Along with that, we'll have to actually go ahead and put down the attribute name. So there's state, there's current value, then value, I know the spelling. So change, then percent change, and one more thing, market status. So now what we want to do is that we want to keep on printing these values again and again. So let's go ahead and style our table a little so it looks more like a table than whatever it looks like. So let's go ahead and do one thing, that I'll paste it over there only, so that I know how many dashes to put in. You can just go ahead and ignore all these things, but I like to keep my data sorted and in an order. So not much of useful work, but why not? So now the data will look linear. You'll see what I mean, to do with all these things, so that whenever we have the data, we will actually have a good representation of it in a tabular format. So while this keeps on going, while we don't want to stop, we still want to collect. What we want to do is that we want to make a request using the requests dot get and get the link from the website. So when we pass this link, we'll get the content of the entire page, not just the value that we want to scrape. From that entire page, what we'll have to do is we'll have to actually get the data and then store it in a good format. So before doing that, we want to make sure that the data that we want from the website is actually there or not. So if it's not 200, then it means that our data is didn't actually get fetched. So if this happens, then uh, let's just say something went wrong. So yeah, something went wrong, and we'll just return the function or raise an exception, whatever you want to do. But for now, let's just let's just return the function with a null value. So soup is beautiful soup. What we want to do is that we want to convert it into a beautiful soup native format, so that we can actually perform different operations using beautiful soup over the data that we get from the website. So basically we get HTML data from the website, or the source data that is present on the website. Minimize this. So now our soup is basically ready, whatever you want to call it, but it's basically called a soup. So now we want to get data soup dot find. What we want to find is that particular data from the entire page. So how are we going to find it? So def, then I'll say class, and then the class will be the class that we just tried to find. So yeah, this will give us the data that we want to get out of the website, this particular numeric data that was present on the website. After that, we'll go ahead and say that whatever data we have, we want to get the text out of that data, and then separate will be new line. So if you go ahead, keep on analyzing the data, you'll start understanding why all these separations and all these formatting techniques are necessary. We'll be using relibrary for this as well in a while after a few steps. But yeah, so this is basically how we perform different operations. So just to get a gist of it, let's print current and see what it actually represents. So I'll just go ahead and start running. What it says is, if I mean, okay, so I'll have to add an except block as well, since I've already added the try block. I'll have to add an except block. So in the accept block, what we want to do is that whenever we are satisfied with the amount of data that we have scraped, we want to stop scraping. So we'll stop it by a keyboard interrupt. So whenever a keyboard interrupt occurs, we'll say that we just ended our entire operation, and we'll note the end time same as the start time. So I'll just copy it directly from here, paste it, and then what we'll do is we'll create a data frame using the pandas library. So pd data frame, so the data frame will have data equals to output that we just that we created on in the very beginning. So hold on, yeah, so output. Now what we want to do with this output is that we want to add columns to it. So what the columns will be, the columns will be these different values that we are actually scraping. So just copy that, then paste it here. So these are the column values that that is going to be stored in whatever uh, our data frame. So now what we want to do is that we want to save this data frame to our memory as well. So df2_csv, we want to store it in a csv format. So we will save it by calling it by the name symbol and then underscore underscore, then plus, then the start time, then again let's go ahead underscore underscore, then end. So yeah, this is basically going to be the name, as well as we'll just add the format in which we have to save it. And just for the sake of tidiness, let's go ahead and print that the data was saved current output as, and this name. So just copy it again and paste it over here. So whenever we have an exception, whenever we accept, we will do this operation. So now let's go ahead and try to run this. Let's see what we get. So as of now, as you can see that we aren't getting much data, but okay, there's an error, that's why we aren't getting a data. So it will be requests, yeah. So now the data that we wanted to get is actually getting printed. It will show an exception, but because we haven't actually created whatever the columns that we want and everything, so for now it won't actually work if I press Ctrl+C. But the main point is that this data is actually getting collected, and now what we want to do is that we want to put that in a particular format. So we'll go ahead and start putting it in a format that we want it to be. So now let's just remove this, add a few spaces, then we'll create a for now let's create a split. So split equals to re dot find all, and then we'll say we want to find everything that looks like this. You don't actually have to worry about this library, just the kind of formatting. It's particularly text formatting or raw text formatting library. So we'll do this, and we want to split data here. So this should actually do. Not this, do that. So this was, we create a split in the data. Now for every record we want to store everything in a record. So what we'll do is we'll start appending. So we'll append the current 0, Did we format it? No. So we will have to format current 1, then we'll store current 0 here, and what we'll do is we'll replace, since there are commas in the value, we'll replace the commas with just empty spaces. Yeah, that works. Current value 0, no, this is to be done. Yeah, now that this should work. Also, we'll go ahead and let's just copy this entire thing, then we'll add it again. So here it should be split 0 and it should be split 1. Now if the market is open, there will be a open in current 2 at close or at close. This is what current 2 right now is. This was our current 1, which we split into this part and then this part separately. So what we were doing is that we were ignoring plus minus, we were just storing this, then we were ignoring again this particular plus symbol that is there. Okay, so all these operations, the splitting of this particular string is done through re library. So now if there is open in current 2, which basically stores this, so right now it says it's closed, but if there's an open in that, then we'll say rec dot append and we'll append an value of open, else rec dot append close. So we'll append close. Now we'll just go ahead and add this to output. So output dot append record. At last, what we want to do is we want to constantly print the values. So we want to print, the format should be simply similar to what we already had. So 5 spaces, this. So I'll just copy this and change the values accordingly. Copy this much. Okay, manually. It's a trouble to do this. So just copy this, paste, 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 1 2 3 4 and 5. So we don't actually need a string here, we will need a float value here, again a float value, again float, and then a string. So yeah, so date is going to be float, string, then we have this value 1412 point whatever, then we have a float value for this, float value for this, and last, if the market is open, it will say open, it will say close otherwise. So now after this, what we want to do is we want to put all the values that we want to show there. So rec0, rec1, rec2, and just rec3 and rec4. So basically that. rec2, then just going to change it to rec3, then rec4. So this will continuously keep on printing our data to the console. Now when this is done, what we want to do is that we want to set up this for the this particular function to perform the operation at regular intervals. So what we want to do is pass interval here. So the function will sleep for this interval, then again wake up, then again perform whatever task is assigned to it, and then again sleep, then keep on going over and over like that. So yeah, now okay, do I have it spelled wrong? Interval. Okay, so now I'm guessing everything is done. I don't see anything missing from the function. So now let's go ahead and run the script and check if it outputs as we want it to or not. So yeah, So it outputs the date, it outputs the current value, it outputs the change and the percent change, as well as market status, if the market was open during this duration or not. So we have collected sufficient data, and now we want to store this data in a data frame or in an Excel file or CSV file, whatever you want. We have given as the format as CSV as of now, and now we stop the script. So when we stop the script, we see that a new file gets created, and it says it gets created in the name 2020 06 06 14 01, whatever. Let's just check one. So yeah, the data is getting collected as we want it to. We then can go ahead and import the data in our data frame, in pandas data frame, and perform different EDA or different, we can build different models and all these kind of stuff we can actually go ahead and perform on this data. So this basically works. So this basically summarizes uh, the third module of our data science course. uh, so what we basically covered in this particular module is that we started learning about different classifications, and then we went ahead and saw how EDA is performed and how all these operations can actually uh, create an impact over the predictions of the model. And we then built a function to actually built a method actually to collect data from the web. And there can be different sources. For example, you can go ahead and collect data using IoT devices and all these things as well. You can go ahead and collect data from user experience and all these things as well. So yeah, there are different techniques. Web scraping is one of them. Then comes dimensionality reduction. So we'll not go ahead and discuss much on dimensionality reduction. I just put there for the context because we were discussing all these things, so why not. So dimensionality reduction basically means that our data is represented by different attributes, and each attribute can actually represent one dimension. For example, if we go ahead and assume that there are two attributes, height and width of something, some shape, then depending on the height and width, if we put different shape at different points, then we can actually graph them. For example, if height is 50 and width is 20, then we can put that on a graph at a particular point. If height is 10 and width is 2, we can put it in different point in the same graph. So yeah, it is a graphical kind of representation, and all these attributes actually represent the dimension of the data. So what happens is that some data, like we just saw, one of housing data set, is of very high dimension, like 80 plus dimensions, and we can't actually process that kind of data simply by just performing a simple machine learning task. So yeah, what we do is we perform different dimensionality reduction techniques, different operations. We bring the data down to fewer dimension, we analyze and we check if some dimension is important or not. We perform different operations, and then we decide how to actually put the data through the model. So this is the very basic concept of dimensionality reduction. It has a broader understanding, as we will have a broader understanding as we go ahead and look at PCA and TSNE, but for now we'll keep that limited to just this much. So all the resources related to third module are actually uploaded already on the GitHub repository, so you can go ahead and check them as per your wish, and there are some support documents as well. So yeah, you can go ahead and check them as well. So thank you. This basically covers the third module.